Space hides more strangeness than our boldest science fiction. We are about to journey through 25 of the most bizarre objects ever discovered in the cosmos. By the end, you will possess a new perspective on just how weird our universe truly is. We will encounter a signal so powerful it was scribbled "wow," and a star that dims in ways no one can fully explain. What cosmic mystery do you think could rewrite our understanding of reality itself? Our journey begins not in the void between stars, but within our own solar system, perched atop a world of gas and ice. At Saturn's North Pole, a perfect geometric shape endures, a hexagon of swirling cloud larger than our entire planet. This is not a fleeting storm but a permanent atmospheric feature, a six-sided jet stream with winds screaming at over 300 miles per hour. How can a perfect hexagon, a shape you might doodle in a notebook, form naturally in a planet's chaotic atmosphere? It defies every conventional rule of meteorology we understand. The Cassini spacecraft gave us our first clear view of this staggering phenomenon, its imagery revealing a structure so precise it appears almost artificial. One leading theory suggests that deep inside Saturn, rotating fluids create a phenomenon that shapes the high-altitude clouds into this polygon. It is as if a giant, invisible cookie cutter is pressed into the planet's atmosphere. This persistent hexagon serves as a humbling reminder that the laws of physics can manifest in ways far stranger than we ever anticipated right in our cosmic backyard. From a geometric storm in our own solar system, we leap into the deep silence between the stars, where a single burst of sound still echoes through the decades. In the summer of 1977, a radio telescope at Ohio State University known as the Big Ear was engaged in its routine scan of the heavens. Its purpose was to listen, to sift through the cosmic static for any signal that stood out from the natural background noise. On August 15th, it found one. For 72 incredible seconds, a powerful, narrowband radio signal blazed into the receiver. It was not the random hiss of a quasar or a pulsar. This was a focused transmission, a scream in the silence that perfectly matched the profile of a signal predicted to come from an intelligent extraterrestrial source. The data printed out as a string of letters and numbers, and when volunteer astronomer Jerry Amon saw the readout the next day, he was so stunned he circled the sequence and wrote one word beside it in red pen. Wow, that single word gave the signal its immortal name. The wow signal was more than 1,000,000 times stronger than the ambient noise of space. It appeared to originate from a region near the star group Sagittarius, and then, just as suddenly as it arrived, it vanished. Despite decades of repeated searches, it has never been heard again. This singular event remains one of the most compelling mysteries in the search for cosmic company. Was it a message that we briefly intercepted, a cosmic hello that came and went before we could even respond? Or was it some bizarre, never-repeated natural phenomenon we still do not understand? The wow signal stands alone, a tantalizing and unanswered question mark in the vast quiet of the universe. While the wow signal remains a ghost in the machine, a cosmic whisper we could never pin down, other celestial mysteries are permanently etched against the blackness of space. Gaze upon Hoag's object, a galaxy that defies every common classification. It is not a swirling pinwheel like our own Milky Way, nor a simple elliptical blob of stars. Instead, it presents itself as a nearly perfect ring of brilliant blue, a cosmic donut floating in the void. At its very center sits a dense, spherical core of ancient yellow stars. Surrounding this core is a vast, dark, and seemingly empty gap, and beyond that gap floats the stunning, separate ring of younger, hotter blue stars. This perfect circle, set against the velvet black of the universe, looks less like a naturally formed galaxy and more like a piece of celestial art. The mystery lies in that profound emptiness between the core and the ring. How could such a structure form? One leading theory suggests a galactic collision billions of years ago, where a smaller galaxy shot straight through the heart of a larger one. The gravitational shockwave from this event could have rippled outwards, compressing gas and dust into that perfect circle of new star formation, leaving the old core untouched in the middle. Yet, no evidence of that disruptive smaller galaxy remains, and the symmetry of the ring is almost too perfect. It presents a beautiful, silent question about the violent and yet strangely orderly processes that can build the universe. But what if a star itself began to act strangely, flickering in a way that defied all logic? Far out in the constellation Cygnus lies a star known as KIC 8462852, but most call it Tabby's star, after the astronomer Tabitha Boyajian, who first brought its mystery to light. Data from the Kepler Space Telescope revealed a pattern of dimming unlike anything ever seen. Stars can dim slightly when planets pass in front of them, but this was different. The light from Tabby's star didn't dip in a regular, predictable rhythm. Instead, it plunged by enormous amounts, sometimes over 20%, in chaotic, asymmetrical dips that lasted for days or weeks. It was as if someone was randomly throwing enormous, opaque shapes in front of the star. The strangeness did not end there. Long-term studies showed that the star's overall brightness was also slowly, inexplicably fading over years. The most tantalizing and controversial early theory suggested we might be witnessing a vast alien megastructure, a Dyson swarm under construction blocking the star's light. While captivating, scientists sought more natural explanations. Could it be a colossal swarm of comets shattered by a planet's gravity, creating a vast, uneven cloud of dust and debris? Or perhaps the star recently devoured a planet, creating a temporary shroud of orbiting material. The most recent evidence points to an immense, uneven cloud of fine dust particles as the primary culprit. This dust dims different wavelengths of light in a specific way, which matches the observations far better than solid megastructures. Yet, the ultimate origin of all that dust remains an active puzzle. Tabby's star taught us that the universe can produce phenomena so bizarre they momentarily stretch our imagination to its limits, forcing us to consider every possibility from the mundane to the truly cosmic. Even starlight's final act can defy simple geometry. Drifting thousands of light years from Earth in the constellation Monoceros is a structure so oddly perfect it was named the Red Rectangle. This is not a classic billowing cloud of gas. Through powerful telescopes, it reveals itself as a set of stark, concentric rungs, forming a shape that looks less like a cosmic explosion and more like a celestial ladder or a vast crimson honeycomb viewed from the end. This bizarre architecture stems from a dance of death at its very heart. Two stars locked in a tight gravitational embrace are the architects. As one of these aging stars nears the end of its life, it sheds its outer layers into space. But instead of expanding in a simple sphere, the powerful gravitational influence of its companion star squeezes this outflow, funneling the gas and dust into two opposing cones or lobes. From our vantage point on Earth, we are looking directly down the barrel of one of these cones, which creates the illusion of a rectangular box. The X-shaped spikes that give it its distinct corners are thought to be bursts of denser material, ejected periodically from the binary system and casting shadows that we see as dark lines within the glowing gas. Adding another layer of mystery to this crimson tableau is the nebula's profound color, a deep, rich red that comes from a class of complex organic molecules known as polycyclic aromatic hydrocarbons. These are essentially the building blocks of soot, and their abundant presence in a place like this is a tantalizing clue. It suggests that the very ingredients for the chemistry of life are being forged in the chaotic, beautiful depths of stars and scattered into the void on these strange geometric winds. While our telescopes peer outward for alien megastructures, a persistent legend insists that one has been orbiting our own planet for centuries. This is the story of the Black Knight satellite, a supposed piece of ancient alien technology silently circling Earth. The tale weaves together misinterpreted signals, real space debris, and a heavy dose of science fiction. It began with claims that Nikola Tesla intercepted a repeating radio signal in 1899, and that amateur radio operators picked it up again in the 1920s. Decades later, in 1960, Time magazine reported that the US Navy had detected a dark, unidentified object in a polar orbit. At the time, this was deeply puzzling, as neither the Americans nor the Soviets had yet launched anything into such a trajectory. The mystery seemed to solidify when, in 1963, astronaut Gordon Cooper reportedly saw a glowing green object during his Mercury flight. These disparate events fused into a single, compelling narrative. The story claimed this was the Black Knight, an alien probe over 12,000 years old, sent to observe human civilization. Photographs from early space missions were said to show a strange, dark object, supposedly the satellite itself. So what is the reality behind this captivating myth? The truth is a collage of perfectly explainable events. The object the Navy tracked was likely a piece of debris, perhaps a thermal blanket, that had come loose during one of their own Discoverer satellite launches. Gordon Cooper's sighting was later confirmed to be a known equipment malfunction that caused a faulty warning light to illuminate. As for those iconic photos, they almost certainly show a lost thermal blanket that drifted away during a spacewalk. The legend was amplified by a single misinterpretation. In 1998, during a Space Shuttle Endeavour mission, astronauts captured stunning footage of a dark, angular object tumbling against the backdrop of Earth. This was not an alien artifact. It was a discarded thermal cover from the shuttle itself, lost just days earlier. The enduring power of the Black Knight story reveals more about us than about space. It shows our deep desire to find evidence that we are not alone, and how easily a series of unrelated, mundane events can be stitched together into a cosmic conspiracy when viewed through the lens of hope and mystery. The universe is not always a quiet place. Sometimes it screams. In a dwarf galaxy 3 billion light-years away, a cosmic object unleashes a fury that defies comprehension. This is the story of FRB 121102, the first fast radio burst ever found to repeat. A fast radio burst is exactly what it sounds like, a blast of radio waves so intense it can outshine 500 million suns, all crammed into a few thousandths of a second. For years, every FRB we detected was a one-off event, a single, catastrophic flash in the cosmic dark that left astronomers baffled and searching for explanations. But then came 121102. It did not just flash once and vanish. It burst out again and again, a celestial beacon firing off salvos of energy at unpredictable intervals. This repetition was the crucial clue scientists needed. It meant the source was not destroyed in the initial blast, ruling out cataclysmic, one-time events like the collision of two neutron stars. The object was surviving its own violent outbursts. How can something produce such staggering energy, not once but repeatedly? The leading theory points to the most extreme objects we know of, neutron stars. These are the collapsed cores of dead suns, city-sized spheres so dense that a single teaspoon of their material would weigh billions of tons. Among them, the most magnetic and volatile are known as magnetars. Picture a magnetar as a cosmic powerhouse, its magnetic field so unimaginably strong that it could erase the data from every credit card on Earth from halfway across the galaxy. Now, imagine such a star orbiting a supermassive black hole or embedded within a turbulent nebula of its own making. The immense gravitational or environmental stresses could trigger starquakes on the magnetar's crust or cause its magnetic field lines to snap and reconnect. These events could unleash titanic bursts of energy, focused into narrow beams that sweep across the universe like a lighthouse. When one of those beams points toward Earth, we see it as a fleeting, brilliant flash. The repeating nature of 121102 suggests its home environment is uniquely chaotic, a cosmic pressure cooker that continually triggers these eruptions. This single, chattering object opened an entirely new window into the most energetic and mysterious phenomena in the cosmos, proving that some of the universe's loudest voices are not dying gasps but persistent, if unpredictable, conversations. While we listen for cosmic screams from distant galaxies, a silent messenger from another star system slipped right past our doorstep. In October 2017, astronomers in Hawaii spotted an object hurtling through our solar system at blistering speed. Its trajectory was the giveaway, a hyperbolic path so extreme it could not be bound by the sun's gravity. This was not a local comet or asteroid. It was the first confirmed visitor from interstellar space, and they named it Oumuamua, a Hawaiian word meaning scout from the distant past. Its origin was a star system far beyond our own, a traveler on a million-year journey that briefly intersected with ours, but this scout was profoundly strange from the moment we found it. Based on its dramatic changes in brightness, scientists deduced its shape. Oumuamua was not a roughly spherical rock. It was wildly elongated, perhaps 10 times as long as it was wide, tumbling chaotically through space like a cosmic cigar. No known asteroid or comet in our solar system has such an extreme proportions, yet the greatest mystery was still to come. As Oumuamua sped away from the sun, something was wrong with its path. Precise tracking showed it was accelerating slightly, deviating from the precise course dictated by gravity alone. With comets, this is easily explained. Heat from the sun vaporizes ice on their surface, creating jets of gas that act like a natural rocket engine, a process called outgassing. But Oumuamua showed no visible coma, no tail of gas and dust that telescopes could detect. It was accelerating like a comet, but it looked utterly inert, like a barren asteroid. This left a gaping hole in the explanation. What invisible force was pushing it? One hypothesis proposed by Harvard astronomer Avi Loeb was as thrilling as it was controversial. Could the acceleration be caused by radiation pressure from the sun? If Oumuamua were extremely thin and lightweight, sunlight itself could push it along, much like the wind fills a sailboat's sail. This would make it a light sail, a piece of natural or perhaps even artificial technology. The idea captured the public imagination, a derelict probe from an alien civilization sailing the galactic currents. The scientific community, however, largely favors a more natural, if still exotic, explanation. Many astronomers now believe Oumuamua was a remnant of a Pluto-like planet from another solar system, a chunk of solid nitrogen ice. As the sun warmed it, the nitrogen would have sublimated directly from solid to gas, providing the thrust for the acceleration without creating a visible dust trail that our instruments could easily see. It would have been a ghostly engine venting an invisible propellant. Yet, because it is now forever out of reach, vanishing into the depths of space, we may never have definitive proof. Oumuamua remains a singular enigma, a brief, silent scout that challenged our definitions of comet and asteroid, and left us wondering what other strange travelers are drifting, unseen, in the dark between the stars. Our own galaxy is caught in a silent, cosmic river, flowing toward an unseen destination. This is the mystery of the Great Attractor, a gravitational anomaly of such immense power that it is pulling our entire Milky Way, along with thousands of other galaxies, through the void. We are moving at an incredible speed of over 1 million miles per hour toward a point in the constellation Centaurus, but what could possibly exert such a force? The answer lies hidden behind the very heart of our own galaxy. The center of the Milky Way is a thick, swirling disk of gas, dust, and billions of stars. From our vantage point on Earth, this central band creates an obscuring veil across the sky, a region astronomers call the zone of avoidance. It is like trying to see a distant city through a dense, permanent fog. The Great Attractor lies almost directly behind this cosmic curtain, its visible light completely blocked from our view. For decades, it was a ghost, a presence we could feel but not see, its influence mapped only by the motion of the galaxies around us. How do you study something you cannot directly observe? The key was to look with different eyes. Radio telescopes and X-ray observatories like the space-based Chandra Observatory can pierce through the interstellar dust. They revealed that the Great Attractor is not a single monstrous object, but rather the core of a colossal supercluster of galaxies, a gravitational focal point named the Oumuamua cluster. This dense knot of matter possesses the gravity to tug on our local galactic group. Yet, the story did not end there. As our maps of the large-scale universe improved, an even larger truth emerged. The Great Attractor itself is merely a waypoint on a much grander journey. The real cosmic current pulling us is an unfathomably vast concentration of mass known as the Shapley supercluster, the greatest gathering of galaxies in our nearby universe. So the pull we feel is a compound force, the combined gravity of the Oumuamua cluster and the distant, overwhelming draw of Shapley. This reveals a universe far more structured and interconnected than we once believed, where galaxies form immense filaments and walls, flowing along rivers of gravity toward the densest points in the cosmic web. We are not merely inhabitants of a single galaxy, but passengers on a voyage whose final destination is shaped by the hidden architecture of everything. A supernova is supposed to be a star's final act, a brilliant self-immolation that leaves nothing behind but an expanding cloud of debris. But sometimes the universe refuses to follow its own script. In the year 1572, a new star blazed into existence in the constellation Cassiopeia, shining so brightly it was visible in the daytime sky. The brilliant Danish astronomer Tycho Brahe meticulously documented this stellar guest, a supernova that now bears his name. For centuries, the remnant of Tycho's supernova was considered a classic case, the beautiful, tangled aftermath of a white dwarf star being utterly obliterated. A white dwarf is the dense, Earth-sized core of a sun-like star that has run out of fuel. It can only explode if it has a partner. In a binary system, a white dwarf can siphon material from its companion star. When it greedily pulls in too much, it crosses a critical weight limit, known as the Chandrasekhar limit. This triggers a runaway thermonuclear explosion so violent it was thought to consume the entire star in a flash, leaving no core behind. Yet, when scientists recently trained the Chandra X-ray Observatory on the heart of this 450-year-old remnant, they found something impossible. A point of light was moving. It was speeding away from the center of the blast at a staggering pace. This was no ordinary knot of gas. This was the surviving core of the white dwarf itself, a zombie star that had endured its own apocalypse. The star had only partially detonated, a fizzle rather than a full bang. It was blown clear of the explosion, scarred and battered, but still intact. This discovery shatters the textbook model of a Type Ia supernova. How could a star cross the critical limit and not be completely destroyed? The leading theory suggests the initial explosion was an asymmetric blast, a cosmic cannon that kicked the white dwarf's core out one side while the rest of the star flew apart in the other direction. Another possibility is a merger between two white dwarfs that produced a lopsided detonation. This zombie star forces us to rewrite the final chapter of stellar evolution. It means that what we thought were the universe's standard candles, the predictable explosions we use to measure cosmic distances, might be more complex and varied than we ever knew. If a star can cheat death, what other fundamental rules might we have misunderstood? While our galaxy is pulled by unseen forces, another has remained eerily still for eons. Nestled within the Perseus cluster, a mere 220 million light-years away, lies a cosmic fossil known as NGC 1277. This is not a vibrant, star-forming spiral, but a dense, compact lenticular galaxy, and it has lived a life of profound isolation. For 10 billion years, nearly the entire age of the universe, it has not collided or merged with any other galaxy of significant size. It is a pristine time capsule, a relic from the universe's chaotic youth that somehow avoided the galactic collisions that built most large galaxies we see today. Its composition is the true shock. Most galaxies of its mass are a vibrant mix of stellar generations, with bustling nurseries of young, blue stars and quiet neighborhoods of ancient red ones. But when astronomers peered into the heart of NGC 1277, they found a stellar population that defies this model. It is almost entirely composed of ancient red stars. The vibrant blue light of hot, young stars is conspicuously absent. It is as if this galaxy used up its initial supply of star-forming gas in one frantic burst of creation billions of years ago and then simply stopped. It became a cosmic dead zone, a galaxy that cannibalized its own potential for future life, leaving behind only the aging, red remnants of its first and only generation of stars. How could a galaxy so massive run out of gas so completely and so early? One theory suggests its ferocious initial burst of star formation, combined with powerful outflows from its central supermassive black hole, may have blasted away or heated up all the remaining hydrogen gas, preventing it from ever cooling down to form new stars again. It is a galaxy frozen in time, a living snapshot of what the universe's first giant galaxies may have looked like, challenging our understanding of how such colossal structures evolve and die. Just when we thought a diamond was the hardest substance known to us, the universe forged one on a planetary scale. Orbiting perilously close to its host star, 40 light-years away in the constellation Cancer, is a world called 55 Cancri E. This is not a terrestrial planet of rock and iron like our own. It is a super-Earth, a world with twice the width of our planet and 8 times its mass, composed primarily of carbon. The conditions there are a carbon copy of hell. It orbits its sun in a mere 18 hours, a year that passes in less than a single Earth day. This proximity locks the planet in a gravitational embrace so tight that one hemisphere permanently faces the star, broiling under temperatures that can soar to 4,700 degrees Fahrenheit, while the other side is locked in perpetual, scorching darkness. This incredible heat and the immense internal pressure from the planet's massive gravity are the cosmic forges that create its impossible nature. Deep within, the carbon is subjected to pressures millions of times greater than what we experience at sea level. Under these extreme forces, the atomic structure of carbon is forced into a rigid, crystalline lattice. The entire interior of this world is likely a single, massive diamond, a gemstone of staggering proportions. Imagine a landscape not of silicate rock but of solidified carbon. Its surface could be a graphite crust, the same material in a pencil lead, shimmering above a core of pure diamond. Some theories even suggest that with the right conditions, it might literally rain diamonds in its atmosphere. This world is a testament to the universe's alchemy, proving that the very stuff of life, carbon, can be transformed into the ultimate symbol of wealth under the right, or rather, the most extreme of circumstances. Yet, even amid such cosmic abundance, vast deserts of nothingness stretch across the heavens. Drifting through the constellation of Boötes lies one of the universe's most profound silences, a region of space so empty it has been called the Great Void. Imagine a spherical volume of space 330 million light-years across. In a universe teeming with galaxies, a region this large should contain at least 10,000 of them. The Boötes void holds perhaps 60. This is not merely a sparse neighborhood, it is a cosmic chasm of staggering emptiness, a hole in the fabric of the cosmos so vast it could swallow our entire local group of galaxies without a trace. How can such a void exist? The prevailing theory of cosmic structure offers a clue. We believe the universe resembles a sponge or a vast cosmic foam, with galaxies clustering along the dense walls of immense bubbles. The voids are the empty spaces inside those bubbles. Most voids are relatively small, but the Boötes void is a giant. It may be what astronomers call a supervoid, the result of several smaller voids merging together over billions of years, their combined emptiness creating a single, staggering vacancy. Another, more speculative idea suggests it could be the scar of an ancient collision with a parallel universe in the multiverse, though this remains firmly in the realm of theoretical possibility. Gazing into this void forces us to confront the sheer scale of cosmic structure. The emptiness is not a flaw, but a fundamental feature of the universe's architecture. It is a humbling reminder that the glittering tapestry of galaxies we see is merely the bright filament in a cosmic web, a web woven around profound and silent deserts of dark. Rising from a turbulent sea of cosmic gas, a 3-light-year-tall pillar stands as a monument to creation itself. This is the Mystic Mountain, an iconic structure within the Great Carina Nebula, captured in breathtaking detail by the Hubble Space Telescope. It is not a solid mountain of rock, but a colossal, billowing tower of cold gas and interstellar dust, sculpted by the very forces it contains. Within its dark, dense folds, a stellar nursery is in a state of violent and beautiful chaos. The pillar is being eroded from within as newborn stars, buried deep inside, fire off intense ultraviolet radiation and powerful stellar winds. These forces blast away at the surrounding gas, carving the pillar's intricate shapes and causing its surface to boil and bubble. You can see these effects as the wispy, streamer-like protrusions along the pillar's ridges, glowing under the relentless assault. At the very peak of this cosmic mountain, a fiery jet of gas screams into space, a telltale sign of a newborn star still gathering material from a surrounding disk. This is the fundamental struggle of star birth, a process where the very material that forms a new sun also works to destroy its own cradle. The Mystic Mountain is a temporary structure, a cloud that will be completely dissipated within the next million years, leaving behind the glittering, newly formed star cluster it once protected. It is a fleeting masterpiece, a snapshot of the universe's endless cycle of construction and destruction, where the most stunning vistas are born from the most turbulent processes. Some stars live on the edge of self-destruction, and Eta Carinii is a testament to that cosmic brinkmanship. Located about 7,500 light-years away, this is not one star but a volatile binary system, and its primary component is a true monster. It is a luminous blue variable, a rare class of hypergiant star so massive and unstable that it barely holds itself together. For scale, the larger star contains the mass of at least 150 of our suns, and it shines with the fury of 5 million. In the 1840s, Earth-bound observers witnessed this instability reach a fever pitch. Eta Carinii underwent what astronomers call the Great Eruption, becoming the second brightest star in the night sky for over a decade. It did not explode as a supernova, however. Instead, it experienced a colossal stellar tantrum, violently ejecting enormous amounts of its own mass into space. This expelled material formed the beautiful and bizarre Homunculus Nebula, a twin-lobed cloud of gas and dust that now envelops the entire star system. Shaped like a vast cosmic hourglass, this nebula is the ghost of that ancient eruption, a permanent scar from a star that nearly tore itself apart. What could cause such a paroxysm? The leading theory points to the star's immense radiation pressure. The energy produced within its core is so tremendous that it overwhelms the star's own gravity, causing its outer layers to balloon outward until they are literally blown away in these episodic outbursts. The danger is far from over. Eta Carinii is a ticking time bomb expected to end its life in a supernova or perhaps even a hypernova at any moment in astronomical terms. When it finally does go, the spectacle from Earth would be unforgettable. It could shine as brightly as a full moon for weeks, visible even in broad daylight. While it poses no threat to life on our planet, such an event would be a front-row seat to one of the universe's most powerful and illuminating cataclysms. A final, brilliant performance from a star that has been rehearsing for its own death for millions of years. The cosmic background radiation is the oldest light in the universe, a near-perfect thermal echo of the Big Bang that blankets all of space. Yet this fossilized glow is not perfectly uniform. One region in the constellation Eridanus stands out as profoundly different. This is the cold spot, a vast and puzzlingly cold patch in the cosmic microwave background that stretches over 1.8 billion light-years across. It is not just a little cooler than its surroundings. Its temperature deficit is so significant that it defies easy explanation by our standard models of cosmology. What could leave a chill of this magnitude imprinted on the very fabric of the infant universe? One leading theory proposes a colossal emptiness. If a giant supervoid, an immense region of space with far fewer galaxies and dark matter than average, existed between us and the cold spot, the light from the cosmic microwave background would have to pass through it. According to the laws of general relativity, as photons travel into a gravitational well, they gain energy, and as they climb out, they lose it. But in an expanding universe dominated by dark energy, a vast void acts like a reverse hill. The photons lose energy as they enter the underdense region and cannot fully regain it as they leave, causing a net energy loss that we observe as a temperature drop, an effect known as the integrated Sachs-Wolfe effect. The problem is, for the cold spot we see, the supervoid would need to be of a size and emptiness that strains credibility, far larger than any other void we have ever mapped. The statistical unlikelihood of such a perfect cosmic coincidence has led to a more breathtaking and controversial alternative. Some cosmologists have suggested this chill could be the bruise from a primordial collision with another universe. In the multiverse theory, our universe is one bubble in a vast cosmic foam, and the cold spot could be the imprint where our bubble once grazed another. The energy transferred in such a contact could have drained away from that region of our cosmos, leaving it permanently colder. While this idea is a profound leap, it is not the preferred explanation for most scientists who continue to search for a more conventional cause within the known laws of physics. The debate over the cold spot remains active, a testament to the fact that even our most fundamental snapshots of reality can contain anomalies that challenge our deepest understanding of where and what we are. Even the most terrifying fictional eyes can find their mirror in the cosmos. Drifting 50 million light-years away in the constellation Canes Venatici, the galaxy NGC 4151 presents a central region so strikingly familiar it has earned the nickname the Eye of Sauron. At its heart blazes an intensely bright, star-like point of light, the active galactic nucleus. Encircling this brilliant pupil is a perfect dark ring of cold dust and gas, which is in turn surrounded by a hotter, glowing ring of material. The entire structure, with its stark contrast and concentric geometry, looks exactly like the malevolent eye from Tolkien's epic fantasy, a cosmic gaze staring out from the depths of space. This is not a work of art, but a violent engine of physics. The searing brightness at the core is powered by a supermassive black hole, a gravitational monster containing tens of millions of times the mass of our Sun. This black hole is not dormant. It is a glutton actively feeding on the surrounding galaxy. As vast quantities of gas, dust, and even entire stars are pulled into an accelerating disk around the black hole, this accretion disk heats up from the immense friction and gravitational forces to temperatures of millions of degrees. It is this incandescent, swirling maelstrom of doomed matter that shines with the ferocious intensity we see as the pupil of the eye. The surrounding dark ring is a cooler, thicker torus, a donut-shaped reservoir of material waiting its turn to fall inward. The outer, glowing ring represents regions where newborn stars are igniting, their formation likely triggered by the immense energies pouring out from the central engine. This single, terrifying visage perfectly illustrates the life cycle of a galaxy, where a destructive force of gravity at the center can paradoxically ignite the fires of creation in its outer reaches. It is a stark reminder that the universe can craft faces of both beauty and terror, each telling a story of unimaginable power. A single ghost pointed the way. In 2018, deep within the ice of the South Pole, a particle detector known as IceCube registered a tiny, almost impossible flicker. It was not a flash of light or a burst of radio waves, but the signal of a neutrino. Neutrinos are often called ghost particles because they are so ethereal. Trillions of them pass through your body every second, leaving no trace. They have almost no mass and no electric charge, allowing them to travel across the universe in a straight line, unaffected by magnetic fields, piercing through planets and stars as if they were not even there. But this particular neutrino was different. It carried an enormous amount of energy, 1 billion times more than those produced in our sun's core. For the first time, scientists could trace its path back to a source. That path led directly to a blazar, a monstrous galaxy 4 billion light-years away, whose central supermassive black hole was firing a jet of radiation and particles directly at Earth. This single ghostly messenger solved a mystery that was a century old. Since the early 1900s, we have known that Earth is constantly bombarded by high-energy cosmic rays, which are fast-moving atomic nuclei. But because cosmic rays are charged particles, their paths are bent and scrambled by magnetic fields as they travel, making it impossible to know where they came from. Neutrinos, however, are the perfect cosmic couriers. They travel in a straight line from their birthplace. This one high-energy neutrino was the smoking gun, proving that cataclysmic objects like blazars are the powerful accelerators responsible for creating these mysterious cosmic rays. This event marked the dawn of multi-messenger astronomy, a new era where we no longer just look at the cosmos, but also listen to its ghostly whispers and feel its elemental particles, weaving a complete story of the universe's most violent events from different threads of evidence. A world like this should have been annihilated long ago. Orbiting a star 620 light-years away, NGTS 4b is a super-Earth that defies a fundamental rule of planetary science. It lives in a place astronomers call the Neptunian Desert, a region so close to a star that it is blasted by intense radiation. In this scorching orbital zone, planets with atmospheres are not supposed to survive. The stellar winds and heat should have stripped away their gaseous envelopes, leaving behind only barren, rocky cores. Yet, NGTS 4b persists. It is about 20% smaller than Neptune and 20 times the mass of Earth, a dense world that somehow retains a thick, puffy atmosphere while completing an orbit in just 1.3 days. How did this forbidden planet endure in such a hostile environment? Its very existence challenges our models of planetary formation and migration. One theory suggests it was not always this close. It may have formed farther out in its solar system and then migrated inward. If this migration happened recently, within the last million years, its atmosphere might still be in the process of evaporating, and we are simply catching it at the right moment before it vanishes completely. Another, more intriguing possibility is that the planet was once much larger, a gas giant with a massive core. Its original, vast atmosphere could have acted as a shield, absorbing the brunt of the stellar radiation for eons. Once that outer buffer was finally burned away, it left behind the dense, core-dominated world we see today, its remaining atmosphere tenaciously holding on. Or perhaps the star itself was more active in the past and has since calmed down, allowing the planet to cling to what it has left. This rogue world teaches us that the cosmos does not always respect our tidy categories. The Neptunian desert is not entirely barren, and its lone inhabitant is a testament to planetary resilience, a survivor in a zone of cosmic destruction. Our universe may have a current, a secret drift that pulls entire clusters of galaxies in a single, unexplained direction. This phenomenon is known as the dark flow, and its implications are as profound as they are unsettling. For over a decade, astronomers have meticulously studied the motion of massive galaxy clusters by observing a subtle distortion in the cosmic microwave background. As these clusters move through space, the hot gas within them scatters the ancient light, creating a faint but measurable fingerprint of their velocity. The result was a staggering discovery. These colossal structures, each containing thousands of galaxies, are not just moving randomly. They appear to be streaming in a coherent direction at speeds of over 2 million miles per hour, a motion that cannot be accounted for by the gravitational pull of any known structure in the observable universe. Everything we see, from the Great Attractor to the Shapley supercluster, has already been factored in, and still, the math does not add up. This flow points toward something immense that lies beyond the cosmic horizon, a region of space whose light has not had time to reach us since the beginning of the universe. One controversial explanation suggests the gravitational tug of a supermassive concentration, a structure so vast it exists outside our visible cosmos. Another, more mind-bending possibility is that this flow is a remnant of the violent birth of the universe, a cosmic shove imprinted from a time before the Big Bang, when the fabric of reality was fundamentally different. The dark flow remains a hotly debated topic, a ghostly current that hints we are only seeing a small island in a far greater and utterly unseen cosmic ocean. Death is rarely a quiet affair, especially for a star. In the constellation Sagittarius, a cosmic arachnid has spun a web of gas stretching trillions of miles across, a structure so complex it bears the name the Red Spider Nebula. This is a planetary nebula, the final, shimmering shroud cast off by a dying sun-like star, but its form is anything but a simple, expanding bubble. It presents as a bipolar nebula with two vast lobes of gas stretching in opposite directions, resembling the spindly legs of a spider. The true violence, however, lies in the intricate detail. The entire structure is rippled with waves and knots, a turbulent surface that looks less like a cloud and more like a choppy sea frozen in time. These waves are not gentle swells, they are the product of a supersonic hurricane, a wind of particles screaming outward from the nebula's tiny, ferocious heart. At the center sits a white dwarf, the exposed core of the original star. This stellar remnant is unimaginably dense and scorchingly hot, with a surface temperature over 10 times that of our own sun. This incredible heat causes the white dwarf to blast its surroundings with a wind moving at millions of miles per hour. This is not the gentle solar breeze our sun produces, but a stellar gale of unimaginable force. As this supersonic wind slams into the slower-moving gas ejected during the star's earlier death throes, it creates powerful shock waves. These shocks compress and heat the gas, sculpting the intricate ripples and waves we see, and causing the entire nebula to glow with the fierce red light of energized hydrogen and nitrogen. The red spider is not merely a beautiful corpse, it is a dynamic laboratory. Its chaotic structure is a direct fossil record of the dying star's final, violent convulsions, a visible snapshot of how a star's own death throes can tear its remains into such an elaborate and terrifying shape. Even Saturn's own moons refuse to conform to simple expectations. Orbiting within a gap in the planet's ring is a tiny world named Pan, a moon that looks less like a celestial body and more like a piece of cosmic pasta. From a distance, its most striking feature is an immense, razor-thin ridge of material that runs perfectly along its entire equator, making it resemble a flying saucer or, as many have noted, a giant piece of ravioli. This is not a trick of perspective or a surface feature. The ridge is an integral part of the moon's structure, a massive belt of accumulated matter that gives Pan its bizarre, squashed appearance. How does a moon end up wearing a skirt of its own making? The answer lies in its unique position. Pan is what astronomers call a shepherd moon, and its orbit is carved cleanly within the Inca Gap, a 300-mile-wide clearing in Saturn's brilliant rings. As Pan travels along this pristine path, its gravity gently tugs on the ring particles orbiting just outside its lane. These tiny particles of ice and rock are drawn toward the moon, but they do not crash onto its surface in a chaotic manner. Instead, they are captured by its weak gravity and settle into a stable orbit around its equator. Over millions of years, this gentle, continuous snowfall of ring material accreted, building up that extraordinary ridge. Think of it as a cosmic potter's wheel with Pan spinning at its center, catching the dust and ice flung from the surrounding rings and sculpting it into that smooth, equatorial band. This process created a permanent record of the Moon's environment, a frozen history of its gravitational dance with Saturn's rings written in ice. Pan is more than just a celestial oddity. It is a living demonstration of how small bodies can actively shape their immediate surroundings, and in turn be sculpted by them, resulting in forms far stranger than our imaginations could ever conjure alone. Light sometimes carries a memory of the very first dawn. In April 2009, a satellite's detectors screamed to life, registering a flash of energy so powerful it momentarily outshone the rest of the universe combined. This was GRB 090423, a gamma-ray burst, the death scream of a single star. But the true shock came when astronomers measured its redshift, a telltale sign of cosmic distance. The numbers told an astonishing story. This light had been traveling for over 13 billion years. It came from an era when the universe was a mere infant, only 630 million years old. To put that in perspective, our own solar system would not form for another 8 billion years. This was not just a distant object, it was a direct glimpse into the cosmic dark ages, a time when the first stars and galaxies were just beginning to ignite. The burst itself lasted only 10 seconds, a final, catastrophic collapse. Scientists believe the progenitor was a massive, primitive star, one of the very first generations, composed almost entirely of hydrogen and helium. These pioneer stars lived fast and died violently, and their death seeded the cosmos with the first heavy elements, the building blocks for everything that would follow, including planets and life itself. GRB 090423 is more than a record holder. It is a fossilized messenger from the epoch of reionization, a pivotal period when the ultraviolet light from these first stars began to tear apart the fog of neutral hydrogen that filled the young universe. This single, fleeting flash of radiation confirms that such colossal stars not only existed but were already dying when the cosmos was in its earliest chapters. It tells us that the universe woke up to violent and brilliant life far sooner than we might have guessed, setting the stage for the cosmic story we are a part of today. Zeta Ophiuchi is a stellar cannonball, a runaway giant blazing through the galaxy at nearly 54,000 miles per hour. This massive blue star, 20 times heavier than our own sun, is not drifting peacefully through its celestial neighborhood. Instead, it is carving a path of cosmic chaos, plowing through a dense cloud of interstellar gas and dust at unimaginable speed. The result is a breathtaking spectacle, a perfect, glowing arc of compressed material that wraps around the star like a celestial wave. This is a bow shock, a structure similar to the wake that forms at the prow of a ship slicing through the ocean. The star itself emits a fierce stellar wind, a constant stream of charged particles. As this wind slams into the ambient gas of the cloud, it piles the material up, heating it and causing it to glow with the intense energy of the collision. But what could possibly launch a star on such a violent journey? The most compelling theory is a story of cosmic betrayal and explosive death. Astronomers believe Zeta Ophiuchi was not always alone. It was likely once part of a binary system, orbiting a companion star even more massive than itself. That companion lived a short, violent life and ultimately met its end in a cataclysmic supernova explosion. When the partner star detonated, the sudden, asymmetric release of energy acted like a cosmic slingshot, violently flinging Zeta Ophiuchi away from the blast site. The gravitational bond that once held the pair together was instantly severed, and the surviving star was sent careening across the galaxy, a lone traveler on a journey it never chose. We are essentially witnessing the aftermath of that ancient stellar catastrophe. The magnificent bow shock is the ongoing evidence of its flight, a permanent scar in the fabric of space that marks the path of a star running from its own past. These vast clouds of gas and dust pulse with the very rhythm of cosmic life and death, forming a celestial landscape known as the Heart and Soul Nebulas. Officially catalogued as IC1805 and IC1848, these two immense emission nebulas sprawl across the constellation Cassiopeia, creating a stunning pair of stellar nurseries. The Heart Nebula, as its name implies, bears an uncanny resemblance to a human heart, complete with deep, blood-red lobes and intricate, vein-like filaments of dark dust. Its companion, the Soul Nebula, presents a more ethereal, wispy structure, often described as a floating, ghostly embryo or a spiritual essence. Their breathtaking forms are not random. They are being sculpted by the very stars they gave birth to. At the core of the Heart Nebula lies a small cluster of brilliant, young, massive stars, each one burning ferociously and dying young. These stellar infants flood their surroundings with intense ultraviolet radiation. This powerful energy excites the vast clouds of hydrogen gas surrounding them, causing the entire nebula to glow with its characteristic deep red light, the same color as a neon sign. But this stellar radiation is also a destructive force. The relentless stellar winds from these hot stars push and erode the surrounding gas, carving out the deep cavities and delicate pillars that define the nebula's iconic shape. It is a continuous battle where the energy that illuminates the cloud also works to tear it apart, blowing enormous bubbles and triggering new waves of star formation along its compressed edges. Together, the heart and soul present a profound duality, a cosmic representation of both the emotional and the eternal. They are a vivid, ongoing portrait of creation itself, where the violent deaths of massive stars seed the cosmos with the material for new generations, ensuring that the cycle of stellar life continues to beat across the galaxy. From ghostly signals to stellar zombies and ravioli-shaped moons, our journey through the cosmos reveals a universe that thrives on the bizarre. Each of these 25 objects serves as a profound reminder that reality is not bound by our earthly expectations. The perfect hexagon at Saturn's pole, the chilling silence of the Great Void, the diamond heart of a scorched world, they all whisper the same fundamental truth. Our current understanding of physics is merely a starting point, a single chapter in a much grander and stranger story still being written. These cosmic oddities are not mere curiosities. They are the signposts at the very edge of our knowledge, pushing us to ask better questions and to look deeper into the dark. They challenge our definitions of life, of matter, and of possibility itself. So we turn the question to you. Which of these strange discoveries captured your imagination the most? Was it the enduring mystery of the WOW signal, the terrifying gaze of the Eye of Sauron galaxy, or the resilient survivor in the Neptunian desert? Share your favorite cosmic enigma in the comments below. And if your curiosity for the unknown is not yet satisfied, subscribe to continue unraveling the deepest mysteries of space with us.